Aperture! This one's gonna be an easy one. This is the second out of the three ingredients for the exposures necessary for capturing our Milky Way. If you remember in the last course, we learned about ISOs. As a recap, if you remember, with ISO, the minimum ISO you wanted to use for photographing the Milky Way was 1600, and the maximum for a crop sensor or crop frame camera, such as consumer grade camera, is 3200, and the maximum for a full frame camera or full size sensor was 6400. Aperture is the opening on the front of the lens that controls the amount of light that reaches the sensor. The numbers you're seeing here are full stops and aperture. Each F number that you see above is a doubling in the amount of light that a lens will allow through. Starting with f1.4, that is the widest and allows the most light in, and f64 is the narrowest, which allows the least amount of light in. Most lenses today include a multitude of F numbers that are not really considered true stops, and most lenses today only go up to f22 at its narrowest. For photographing the Milky Way, we will be concentrating strictly on these widest apertures. For these apertures are the absolute must to allow enough light in to record extremely dim light from our own Milky Way. Any other aperture just will not allow in enough light to be able to capture that extremely dim light. Ideally, in a perfect world, f2.8 would be the minimum aperture you would want to be able to capture the Milky Way. I know many of you work with only kit lenses, and very few of them actually go as wide as f2.8. But some of them do go f3.5 or f3.8 or even f4, and they will work. You can try going to a narrow f-stop, but then at that point you would have to increase the ISO so high that the noise would be so severe you would not even be able to get a usable image. Or you would have to have a shutter speed length so long that your stars will no longer be points of light, but trails, which does not work very well.